Hey, what's up everybody? This is Steve. We're at Scooter West. We're in a repair shop at Vespa Motorsport. Got Robot on my right, Alex on my left. We're doing 3-cylinder kits today on the new 150cc 3-valve engine. So Malossi came out with a cylinder kit maybe within the last 6 months. It was our first opportunity to install them. Increases the displacement from 150ccs all the way up to 183ccs. There's two different versions of the cylinder kit. The cylinder kits themselves are actually the same. One is for the earlier style of injection system that in North America you'd find on the Vespa 946 and the Piaggio Fly 3-valve application. So those bikes, 2013 was the 946, the Fly was 2014 and 15, and then the Sprints and Primaveras, they have that next generation of injection system, and they use the next generation of cylinder kit. So the part number for the Sprint and Primavera is the M311650. That one right there. Sprint Primavera. Fly 946 is part number 31166669. Like I said, the cylinder kits themselves are the same. So this stuff, the mechanical components are the same. What's different is this programmable and adjustable force master that allows you to, like I just said, program and adjust the fuel injection so you can kind of run different curves and mappings and stuff like that. Since we've got the two bikes off the lift, I'm going to walk back here, and on the Fly, can't recognize it because the Fly, all the body work gets removed, but this is, the throttle body ECU. It's kind of a large cylindrical thing with a good size ECU kind of attached to the outside of it. That would be the ECU, right? This is referred to as the MIU3. Going forward, Robot theorizes that the 2016 Flies will probably start switching over to that other intake system. We haven't seen it globally. There's probably a little bit more confusion because I think they've mixed it up a little bit more, but at least for North America, no confusion from what we've seen so far. Sprints and Primaveras have always been one. Flies and 946 have always been the other. Can we see that, Scott? So this is the throttle body, and it's got a separate ECU, which I believe is back behind the glove box or something, right? So it's just a throttle body. For our Resident Genius Robot, this thing is a lot nicer.
It's a little higher output power.
Yeah, so it seems to seems to perform much better than newer style, which is what you'd expect. So those are the two different intake systems. Getting back to the cylinder kits, like I said, we're going from 150 cc's all the way up to 183 cc's. Or this would also fit on the 125 for more global applications. So for Europe, Asia, the Asian markets, that 125 cc. This thing is a serious upgrade for those. For the North American market, it's just a hardy upgrade. So we go from 125 or 150 cc's up to 183 cc's. The actual bore on a stock cylinder, which we've got taken off here, there's a stock piston, 58 millimeters. The Malossi piston, 63 millimeters. You can really see the size difference when you kind of hold the two flush on one side and on the other. So the standard Piaggio equipment for 150, the 125 would be even smaller. And then there's the 63 millimeter Malossi piston. As far as compression ratios, that's the question everybody always asks. They do about 10.5 to 1 on the stock setup, and the performance, the Malossi stuff is about 11.5 to 1. Diving into what you get with the Malossi kits, we're gonna have Scott zoom in down here and we'll show you everything. First of all, there's the nice high quality Italian made aluminum cylinder, the larger bore. By comparison, we've got a stock one side by side. You can see the Malossi casting marks on them. Talked about the piston, but the 63 millimeter piston, of course, it's going to come with the two upper rings as well as the oil scraper ring. It comes with a new head gasket, a cylinder base gasket that's a little on the chintzy side. Sorry, Malossi, it is. We're going to talk about that with the secondary kit that we offer here at Scooter West. Of course, the wrist pin. Didn't take that out of the bag, not exciting. You've seen one wrist pin, you've seen them all, and the wrist pin clips. And then of course they come with the two different Force Master ECUs. This one that's out of the box is the actual Sprint and Primavera one. Robot is actually going to take us through the step-by-step installation guide for getting the engine out of the bike, disassembling the engine, and then of course putting the stock top ends. He's actually already done some of that, so we're going to be diving back in with him shortly. But aside from the product overview, Not sure what else I can say about it. Let's get down to the installation of M3116550 and 3116669, 183cc cylinder kit from Malossi for the new Sprint Primavera Piaggio Fly 3-valve 125, 150cc applications. Let's get to it.
All right, we're going to jump into pulling this motor out of the Sprint here. And the first major step in order to install the cylinder kit is you got to get the motor out. Pretty much doing this job on a Primavera, it's identical. Only difference is the gear ratio in the final drive and the larger wheel. Everything else is the same. You can see our other video on pulling the motor out of this Fly. And the Fly is going to be, you know, mildly similar to the 946 too. The 946 is quite a unique scooter. We're not going to do a video on that, even though we have experience putting kits on them. But we're going to jump into this and we'll get the motor out in the next 15-20 minutes. All right, the first step is you're going to have the scooter clamped by the front wheel. It's going to be the safest way to pull the motor out. As you can see, it's on a lift right here. So the front tire's clamped, and I have a scissor jack in the middle, you know, which allows us to lift the frame but leave the motor behind. If you're doing this job at home, you can improvise with, you know, using blocks of wood. You can make like a support that will tie the front end down via the handlebars to kind of stabilize the scooter. There are a couple different ways. You just need to use a little ingenuity, you know, and on improvising if you don't have a lift like this that clamps the wheel or a jack. But definitely it can be done without this stuff here, but makes the job a little easier when I can raise the scooter to the level that I need to perform the job. All right, so first of all, I'm going to pop the seat. Pretty straightforward. And oftentimes I recommend disconnecting the negative terminal on the battery. I'm not going to touch the ignition switch. There's nothing that's live in here. It's all isolated by a relay. So I'm just going to leave the battery on there just for simplicity's sake. We're going to have to disconnect many of the connections and hoses from this area, kind of the top of the engine per se. And we'll go ahead and remove the muffler, get that out of the way. And I'm going to drain the oil because this scooter's got a couple thousand miles on it. I'm going to put non-synthetic oil back in it, and that's just for the break-in of the engine. Usually I tend to like to use non-synthetic for break-in and then go back to the factory recommended synthetic once you change that oil out after 300 to 500 miles. All right, so before I get going on the motor, I'm going to go ahead and get the oil drain. You can see I don't have it on the center stand because these engines tend to want to drain the oil on the center stand. So kind of easier if you lift it up a little ways. 24 millimeter wrench. And break the drain bolt free. And by the way, I'm working on the right side of the scooter here. And gotta be careful, this would be hot if you just, you know, came off riding the scooter. It's cooled off. And there we go. We'll drain the oil. Doesn't look all that bad. O-ring, discard that. And you got the oil screen comes out. You want to inspect that every time. And it looks pretty clean. I see a couple little grits in there and you can clean that out. So I'll leave that off to the side. While that's draining, I'm going to actually get started on loosening many of the fasteners that you need to loosen to start the job here. All right, working from the left side of the motor while the engine oil is still draining. I'm going to go ahead and remove this fastener. It's a T30 Torax. And if you lift on this a little bit, you'll be able to remove this little corner piece. You don't necessarily need to remove it, but it's just a little bit in the way. You want to keep it from getting scratched. Have that removed, you need to cut the little zip tie from that little air intake for the belt cover, T25 Torax. Remove that cover there. And underneath here is the rear brake cable. but there's actually 2 cable clamps that hold this brake cable in place. And these 2 you don't need to remove on the Primavera and Sprint, but there's 2 that hold to the belt cover that you need to remove. So this clamp stays with the brake cable. This one, you can actually release it. Put those to the side. 10mm wrench. You want to loosen that lock nut. And the next step, we're going to go ahead and loosen the air box. It's 2 Phillips fasteners, number 3 Phillips. And they only come out a little ways, but they're very long screws. Pull it out, you can see there's a star washer and a flat washer. Other ones a little more buried, you can use either a magnet or a needle nose to pull it out. Exact same length screw. Set those aside. See, the air box is now fairly loose. On the very front, there's a ground strap terminal. Same, right off the belt cover there. And we're going to go work from the other side here. All right, so pretty much the screen's pretty clean, but you can use, some sort of card spray, brake cleaner, kind of blow out anything that may be in it. Put that back in place. Just sets in there. Brand new O-ring. A little grease on the O-ring. And this is a very important step that seems, a lot of people don't, they're just, you're doing so much on engine. Some people are like, oh, let me just put that back in place and spin it. Okay, well, it's tight. Never come back to go retorque it. So if you're going to put a fastener back that's not going to get touched again, you want to make sure you torque it. And I see a lot of people strip these out and mess them up. Only needs a little. So it's pretty much bottomed out right there. I feel the O-ring almost bottomed out. And not putting too much effort, but just torque a little bit, maybe 20 foot-pounds at the very, very most. Get the oil out of there. And again, remember there's no oil in the engine. You don't want to get so excited that you put the cylinder kit in and then start up and forget to put the oil back in the engine. Not a good thing to do on a brand new motor here. All right. We're going to put a different exhaust pipe on this. And oftentimes if you're changing the tire, I'll show you what you got to do with the O2 sensor here. There's a little teeny O2 sensor right here. And on the Sprints and Primaveras, you could just barely access the little cable clamp that's in here. I don't have a flashlight shining there, but you'll see the screw that comes out. Hit the ground there, but there's a little clamp that actually holds the cable in place. And it's a small thread-forming plastic screw here. And if you're unfamiliar with this motor, it's not a bad idea. Something that you're definitely going to have to reinstall. You could put the screws back in place if you want. But once you've looked at some of this stuff enough, you can there's not too many different fasteners. You can remember where they all go. Pretty simple. So this is your O2 sensor connection. This is the little cable clamp. All I did is stick the flat blade screwdriver in there and twist, and it actually opens it right up. You see the wires trapped right in there. And these things are like one-way little tabs for the connection. And you do 2 ways. You could either just pull the whole connector off, or you could pop the tabs. But you see, it was a little easier, just pop right off. And on this connection, there's a gray locking tab. Get a flat blade screwdriver in there and see it releases right like that. You can either remove the whole thing all the way out, or it will stay in place. And just push that little button right there, and it releases the connection right there. So the O2 sensor is now separated from the harness here. One thing to keep in mind, if you're just doing a tire change, it's kind of a lot of work every time to disconnect this O2 sensor. If you're careful, you can unbolt the exhaust and just, you know, kind of leave it to the underside of the scooter, and you gain enough room just to pull the wheel off. But since we're pulling the motor out, that needs to come out. O2 sensor is going on a brand new pipe. Go ahead and just disconnect it here. All right, 10mm socket. You can go ahead and remove the exhaust, starting from the you see the single, and the other one's a little harder to get to. May want to use a wobble. And there's that nut. Again, with the wobble, it's a little easier to get it off. So you have the two nuts that retain the exhaust flange there, and then a 6mm Allen. Make sure the pipe's not top one. I'm kind of supporting the muffler because it's going to want to drop. Both screws are the same length there, and I'm rocking the pipe up as I pulled it off. Comes right out. Got these two fasteners. They have a special locking washer and a very thick flat washer, and the two copper colored ones for the exhaust flange itself here. So we'll set that aside. One other fastener you need to get to from this side is through the spokes. You can see that 5mm Allen. That's the that's what retains the brake cable. So it's a little easier with the ball, 5mm ball-ended Allen wrench there, and a little doohickey drops out from the other side over here, and the actual screw from this end threads into that, and that's what clamps the cable. So we'll set that aside. We'll disconnect the cable via those two 10mm the lock bolt right here.
Check out the person on his plate. TC just got, dude.
Oh, our #1 sales guy? Is that what you're talking about?
#1 sales guy. Frosted Tips, personalized plate.
Oh yeah.
Paid extra money and got like 5 extra digits. And when you buy and sell 400 Triumphs a month, as a private party individual, I mean, geez, come on.
All right.
Some pull with the DOB.
Back to the subject here. Pop those two out. Get out of here, Steve. Cut a zip tie. Sometimes there's a zip tie on this, and if there isn't one, I'd recommend putting one in there because this little cover is notorious for being extra loose. So that's loose. Ground terminal, of course. This is a little engine isolator. On some models, like the Fly 946, you're going to need to remove it. It's a real tight fit. The bolt barely will get by this when it comes time to remove. But we'll get to that later. All right. Got various connections and hoses that we're going to have to disconnect from this side here. So these are original hose clamps that come on the come with the Vespas, and unfortunately they're only usable one time. So best way to remove them is cut them or slide them off. And that one came off. This is your breather hose. On the Sprints and Primaveras, this is your idle air bypass, and it controls the idle on the scooter. It has an extra little hose that goes to the air box. That came off, and if it's really difficult to come off, use a really good set of cutters or dikes and actually cut this and break it open. I'm not going to reuse those, not really worthwhile. In the trash. All right, removing the hose clamp that holds the actual throttle body to the intake manifold. And I'll loosen that one. It's a little easier than loosening the one that goes into the intake manifold. And again, to me, it's a lot easier to just disconnect the throttle body and leave it with the scooter. Leave the 2 throttle cables with the scooter. Make sure it's not going to scratch up against your frame, but kind of keep it out of the way. I can show you the last of our wiring here. O2 sensor connector. This is all the connections to the left electrical components. Starter, ignition coil, throttle position sensor, the air, whatever you call it, valve, the air control valve thingy. There's another one of these clamps. And again, easy way is just pop a screwdriver in there and get those out. Another clamp there. If you don't have a screwdriver, see how I push down on that one lower tab? It actually will release just as well. And this is the main connection to the charging stator and also the pickup, which tells the engine computer what position the engine's in. So that, with that tab there, disconnects. And as you can see, voila, all the wiring that goes to the engine is now disconnected from the engine. Spark plug cable and all that stuff still hooked up. This ground connection is disconnected. Our rear brake cable's disconnected. The fuel injector, so hence the fuel line's disconnected. Muffler's out of the way. 2 more bolts and this motor's out. All right, we're gonna disconnect the lower mount of the shock here. 17mm wrench on the nylock nut right there. And it's a 13mm for the actual bolt itself. Perfect opportunity to put a upgraded high performance fully adjustable shock in place of the stock unit. And from this side we got a 17mm fastener. And this is the main engine pivot bolt right here. That actually came off without, oftentimes you got to put a wrench on the actual bolt on the other side. Didn't need to do that. So we're going to go ahead and see, I just jacked up the motor, took some pressure off the bolt, and the whole engine dropped down. And from this side, center stands down here and it's on the tire. Rear shock's disconnected. And take a big wrench and pull the bolt out. And it's almost like magic. The motor's almost separated. And since I have this lift setup, I left the rear fender on. If you're doing this at home, you can actually remove the 2 screws here, 2 screws here, and then 2 additional screws. Get this rear fender out of the way. So the motor will pull out without having to lift the scooter frame as high as I'm going to do. So, and you'll see kind of missing the shock. Double check, just make sure you don't have anything still connected. But there we go. Don't roll the motor off the lift here either. But that's the engine. Pretty magical, huh? All right, hey Vespa people, we're back. We're gonna have magic moment number 2. The motor's gonna come apart, and it's extra magical. So start by taking the fan cover off. There's 3 fasteners that need a 4mm Allen, and I have like a quick ratchet drive. Then you get the 2 Phillips screws out of there. So you see they have a special like kind of dome-shaped lock washer. Keep those lock washers with the screws. these self-tapping plastic screws. They have really, looks like a drywall screw or something. Real coarse threads on it. And this little thing will just pull right out. This is your oil pressure sensor. So what I like to do with the hardware that goes to the specific part, sometimes you can use the part as a tray. So I'll set that aside. The hardware will be ready to go when it comes time to assemble. So that's now put to the side. All right, get on the other side here. A couple things we need to remove. We're going to remove the intake manifold, the cylinder head temperature sensor, and the ignition coil spark plug cap. Spark plug cap pulls straight out, and pull the wire. See, it's got this little grommet. It's easier if you just pull the wire right through this little clip, then pass the wire right through. We're gonna leave the ignition coil with this upper plastic cover because I have a one-time use zip tie that holds it in place. No sense in upsetting that. Yeah, let me just. All right, for a little better angle, there's 2 screws that hold this ignition coil that need to be removed. And one of them's back here, or it bolts to the actual cylinder itself. One thing to keep in mind is sometimes they have a longer screw, and when you're installing the screw on the cylinder kit, it may bottom out before it actually bottoms out on the washer. So you may need to trim this screw or install a shorter screw. And that was just noted on the fly motor. It's a slightly different variation of this motor. I took the 2 screws that were holding the starter motor. And the starter motor, you can get a big flat screwdriver between the actual starter and just pry it a little bit, and the friction of the O-rings kind of hold it in place. We'll set that aside with the 2 screws. Only reason you need to remove the starter is for this rear ignition coil mount. And this ignition coil has to come off because one of the screws goes through the cylinder there. So you can see there's some special washers. Make sure those stay with the coil. And there's the 2 screws with large washers that hold the coil, both the same length there. The air temperature sensor, or the cylinder head temperature, it's a 21 millimeter, kind of an oddball size, but pretty simple to remove. If you don't have a deep socket to take it off, you could probably get a wrench in there. Just make sure you don't damage the plastic connector on it, which is not going to function correctly without that sensor. To remove the intake manifold, they have 3 fasteners up here. Unfortunately, they use a special type of Torx with a security pin in the middle. This is a T30 Torx with the pinhole in the middle there. And you're going to need to obtain this style Torx driver to remove this. They're pretty readily available. Most tool shops will have the security Torx, whether you're buying a simple key or something that mounts to a wrench. And it's Torx kind of critical on it. I'm just cracking all the fasteners before I go ahead and loosen them. So they're all cracked. All the same length. Can't really see that one. So those 3 screws. The intake manifold come right off. Sometimes the gasket will stick to the intake manifold. Sometimes it sticks to the head. In this case, looks like it's stuck to the head here. And pull the old gasket off, get it out of the way. As you can see, it tore. Go ahead and replace that. Don't want anything falling in this. In the intake manifold hole, that is. Use a small piece of tape and just put tape over the hole. That keeps anything from falling into it. The shrouds come off pretty simple. On this side, there's a single Phillips screw Again, it's a special threaded plastic screw, kind of long. All three of them are the same style screw. And with those three screws out, that will pull right away. And there's little tabs that engage with these 3 points right here. One last screw to remove the top. Right to the side there has a little washer, Phillips screw, whatever it is, 4mm style screw. And release the little wire for the oil pressure sensor. On your right side, that's right, that little point right there. Now the engine's stripped of all its shrouds. All right, so we're gonna start stripping the major engine components of the top end. I'm pulling this little gasket. That's just a little rubber isolar gasket for the shrouds. Comes right off, can be reused. 4 bolts for the valve cover. You see our other video of how to adjust the valves on a Sprint in Primavera or any of these 3 valve 125, 150 motors, essentially the new style. Except for I made a little blooper in that last video and had the wrong specification for the clearance of the valve. And as you saw, I kind of cracked the fasteners in a crisscross pattern before I actually went ahead and unscrewed them. So the 4 screws, you got this little rubber thing. All this scoop is like the factory grease that holds the gasket in place. Always recommend replacing these gaskets. And I also recommend replacing the gasket that's under here. I've seen a number of them leak. And I can tell you one other thing about this scooter here is TC has complained about stalling, and I've seen a couple other Sprints. See how this is jammed up and doesn't really want to go back down? It's jammed. It should go freely, and I'll show how it should go. So I'm gonna fix that. You got to make sure it's smooth, you know, it has smooth action going in and out. But that's an issue I've seen on a couple of the new motors. Is the this is the yeah. So this is the automatic tensioner device, and I've seen a couple of them kind of bind up, either because the spring's out of place or this plate presses too hard. Before we continue any further, I'm going to find top dead center. You see this little arrow that's right on the whatever you call that, the cam sprocket, the upper cam sprocket. It lines up with this pip right here. It's pretty much the rivet of the chain will be right at that. The thing's still sticking just a little bit. It should always sling right back. So I went ahead and turned the crank via the whatever you want to call that hole there, the air intake hole for the drive pulley sprocket, 19mm socket. You can turn the engine over right through here to get it top dead center. And once you have it at top dead center, this motor is very difficult to find a flywheel mark. You got to take the whole entire, what is that, your right hand cover off, you know, behind a fan. That's a lot of work. You're best off marking your top dead center. So we have our arrow right here and the pit, and it's lined up perfect right there. And the next step is I want to mark one of the fins. You can do it with a paint pen or a Sharpie. So I'm marking the fin, and I'm marking, so I have a little arrow that points perfectly at that fin. And just to show you, say if you put together with the tooth one off, so I'm going to move that one tooth off, you could see that the fin's like a good 8mm away from my little arrow there. So you're definitely going to get it on the correct tooth of the cam timing sprocket when it comes time to reassemble. And that's very critical that that's all set right. All right, so Again, top dead center, arrow pointing at the pip here, and I've marked it on my dry pulley fan and also on the belt case. One other thing you can do is in this little hole, that's a locking hole. And when it's at perfect top dead center, you could drop a screw, put like a 3mm screw in there. A round drill rod would work just as well. And the whole idea is when you go to crank on remove the sprocket, you don't change the timing. So as for this thing sticking a little bit, it's this little plate here, and you can get a screwdriver carefully under it and just bend it ever so slightly to kind of relieve a little pressure on it. Still sticks a little bit, and I could see that it's there's zero clearance between this little plate and this little rocker thing here. So and now it's working pretty good there. So with this screw in here in place, you could actually break the two screws that hold the tensioner on there. Next step is we're going to remove the cam chain tensioner. It's right up here, and this is the spring itself, 10mm socket to remove that. Some of them have an O-ring, some have a crush washer. This one happens to have a crush washer, and that's not what you're supposed to do. But the spring went flying out. Normally you want to catch the little spring and washer. So there's the crush washer, spring, and on some models this is an O-ring, and that's in a well on the tensioner. So definitely remove that before you take the tensioner off. Tensioner is held by two 8mm headed screws here. The two screws, kind of short ones, and the tensioner itself. And you can see this tensioner, it's about 10mm out, and that kind of indicates that the cam chain doesn't have much wear. If you had a tensioner that was all the way out like that, that means your cam chain is completely worn out. There's not really any reason for these cam chains to wear out, but definitely something just to note. And to reset this, it's a one-way ratchet. You want to push the little tab right there and push it all the way in. Retract it all the way to the starting position. And we'll need it that way before we assemble this back into the head. Got a gasket. Malossi Kit includes this gasket. We have two cam chain tunnel 8mm fasteners, real long ones over here, again cracked. See those long screws? They're not used anywhere else on a scooter. Sometimes they're silver, sometimes they're black. All right, 5/8 spark plug socket. Go ahead and remove the spark plug. Much easier job when the motor's out of the scooter frame. The original plug. We'll go ahead and replace that with the finer electrode iridium plug. Now we're going to go ahead and remove the tensioner. Already cracked the two screws. You can see this has got free play in it now just because the actual cam chain tensioner is out. So as you're taking the last one out, that little plate will want to kind of fall away. So went ahead and removed that. To the same screws that hold that. And this is the actual counterweight. It's got a little spring right here. And if you use your nail, you can actually remove that spring. It hooks onto the actual counterweight right there. So I went ahead and moved that away, and it kind of popped, and that's fine. You want to hold both the counterweight and the spring as you remove it. And you can see this little hook hooks into that little hole right there. So counterweight, and leave the spring with it because it only goes on one direction here. Screw that keys the sprocket can come out. and the actual sprocket will pull right away. I derailed the chain, and there's your sprocket. Only goes on one way because there's an arrow that faces on the outside. All right, so we're going to go ahead and remove the head. 4 fasteners, and we want to crack them in a crisscross pattern. So about an eighth of a turn. You can kind of hear them crack. So I'm going to continue doing that until they're pretty loose. So 1/8 of a turn. So they're all loose. Zip all these. Be prepared, a little bit of oil sometimes will come off as we pull the head away. You see it draining out of the cylinder studs. That's normal. Gasket happened to stay with the head. Not going to reuse the head gasket. Pull the 2 dowels out. There's your gasket. We're going to go ahead and clean this head up. The lower cam chain guide comes right out. And as you can see, the piston's at the very top of its stroke right here. And right now this is a little bit stuck. You can use a mallet to give it a couple sharp blows to kind of loosen it up. And it will free up from the, kind of put hands on both sides and go ahead and pull it out. And you can see the piston's exposed, the skirt of the piston. And before, get that all the way out, just drip in a little bit more oil, of course on my tools there. There's the gasket. These dowels pull right out. And if they don't pull out, like they're rusted in a little bit, you could drop a 6mm fastener down in them so you can grab them from the side and carefully wiggle them out. If you distort these any, it'd be a good idea just to replace them. But those 2 dowels come off. And this gasket, is not reused. I could tell you, the factory gasket has the silicone on it. The included Malossi gasket doesn't include that. Got kind of an oil mess. Go ahead and put a rag in there. Grab a fine tip needle nose pliers here. And I'm going to go ahead and pull this out, and I'll demonstrate how you get the pin out. So I'm poking the actual wrist pin right out. And once it's pulled away enough, it's going to separate from the piston. There it is. And I'm going to put the clip back in and demonstrate on how to remove it without. I can tell you this is probably one of the trickiest parts if you've never done this before. So you can see the clip is in this little well. There's actually a groove machined in there. And there's this little pocket right here. And you want to have a fine tip, good quality pair of needle nose. This is, it's got a serrated inside, so it will grab the clip really well, and it's pretty small. There's also a factory tool that installs these. I've used it before, but I prefer using the needle nose over the factory tool. So you stick the needle nose right in the clip, and kind of hold it very firmly, and then kind of push in and pry out. And keep on holding that clip, because if you don't have a strong hold on it, it's going to go flying. So once that's out, the pin will push right through. And if the pin's a little stuck, I recommend using a wrist pin puller and not hammering this through, because if you bend the connecting rod, you'll end up with a cylinder and piston that never wear correctly, and you'll lose compression pretty quickly. But I've found with all these newer motors, the pin generally goes in and out very easily without any resistance. And that concludes disassembly of the motor. Gonna go off to cleaning all these parts up that are gonna get reused and assemble it with the Malossi kit. All right, so we're gonna jump into the assembly of the top end of the engine with the cylinder kit. A couple things need to be prepped prior to reassembly. I got the head. I went ahead and left the cam. You can see it's supported by this large bearing. There's a retaining plate and 2 pins that retain the roller rockers. So right now, it's a top dead center. You can see that thing's really loose at this point. That's where you want it. The valves are retracted in the head. I'm not going to take any of this apart for right now because there's no need to. We want to prep this. Make sure the surface is absolutely flat. Even on a motor that's disassembled and has a few thousand miles, this surface may not be perfectly flat. All right, so you can see there's like a carbon buildup kind of on this flat surface. I'm not too concerned with the stuff in here. It's very light. If you really want to clean it up, you could go in there with a small wire brush or a bronze bristle brush and some card spray and clean that up. But I'm just going to scrape this off, and I'm just using a straight edge razor blade. One thing is keep your finger over that oil hole. Make sure none of these carbon particles go in there. Could score up the cam.
Show us that oil hole again, Robot.
It's right under there. That's the hole where the oil is actually transferred, from the bottom end of the engine, the oil pump, into lubricating all the cam drive parts. So right here I got 400 grit paper on a fairly thick piece of glass. You can see this was like off some little glass table. Oftentimes at a shop you'd have a microflat, which is a precision ground piece of metal, but glass works just as well for this application. This is, especially if it's tempered, it's going to be really flat and straight. So 400 grit, just want to run the head across and kind of hold perfect pressure on it, and you can see that the sandpaper is actually touching all areas. It's kind of got this dull finish all the way around. You still see a little bit of the milling marks from the original machining. Doesn't need much. This head's not, if it's a head that had like 10 or 20,000 miles or was running really hot temperatures, you may need to do this for quite a few minutes, get it flat, on a couple pieces of 400 grit. But all right, and the last step is go with 1,000 grit. This is a real popular finish for doing body work, polishing out clear coat. It's very, very fine. You barely feel the grit in it. But that's like kind of last little bit of polishing. And again, do the same. And it goes from that dull finish that the 400 grit left to a little bit shinier finish. It's never going to become mirror finish. We're not going to 4,000 grit or whatever, but you can see it's pretty reflective and shiny right now in all spots. I don't see any low spots where it looks like the sandpaper hasn't hit it. You can see a real minor ridge there from where the old head gasket was. No big deal right there. So now that you've cleaned the surface, and take a brake cleaner and just spray this whole surface, take a clean part of your rag and wipe this all down. Just want to make sure this is all perfectly clean before it makes contact to the new head gasket. So that's all good there. That's ready to go. One other step that you need to take if you have higher miles is check your valve seals. You want to take this tape off, fill this with water, and with the valves closed, the cam at top dead center, watch this, and there shouldn't be any drips of water coming through. If there's a minor leak, you may be able to lap the valves. I'm not going to cover that in this video. If it's a major leak, you may need new valves, or you may need, send the head off to get machined. And we can handle those services. If you want to send the valve with the whole head to us, we can inspect that as a service. Just see our website for details. And repeat the same with exhaust. You can see there's some remnants of the intake manifold gasket. Again, a little straight edge razor blade. Kind of just get underneath the gasket, scrape it right off. and make sure nothing goes down the intake port. Use compressed air and with the brake parts cleaner, carb spray, or whatever, you know, just make sure that's clean, kind of washes out anything that's in there. This side, you see that exhaust gasket's a little burned out. You know, you can see where it's copper on one side and a little bit more black carbon kind of around. And you know, typically if you're going to put a new exhaust especially, you want to replace this gasket. We're going to put the Malossi exhaust, and I'm using a pick and I'm getting it through the fins, and you can actually pry that thing out. Just a soft copper gasket. All right, so I dropped the copper washer in there. It doesn't just go in on its own. I kind of have a larger size socket, and you could just tap it in place. And of course, when you tighten the exhaust down, it's going to do the rest of the work. But new gasket's in place, it's not going to fall out when we reassemble the head. Head's pretty much ready to go, and on top of the cylinder kit. And clean all the other parts, your cam parts, the sprocket, the valve cover. Go ahead and clean all those parts prior. I've already cleaned this base gasket surface here. Again, you can get in there with a little razor blade. If there's any remnants of the gasket, you can just carefully scrape those out. Just the small leftover remnants. Make sure you don't drop too many of them into the spigot. Wipe this all clean. All right, before installing the cylinder kit, you need to take a couple extra steps to prep it prior to installation. And it's mainly cleaning the cylinder and stuffing the piston part the way in. It's a lot easier to do the way I'm going to show it versus the way some people do and put the piston on the connecting rod. Not a good idea to do it that way. So you got the cylinder. It may look perfectly clean, but there's still some metal residue. And you use something like Simply Green or Purple Power, a degreaser style cleaner. You don't want to use brake parts cleaner. It actually doesn't clean quite as well for this application, getting the metal, the last metal particles out of the cylinder wall. You want to use a clean terry towel. This one might look dirty, but it did go through the laundry. And I used the clean section of it, and I'm just kind of wiping all of the, you can see there's like a gray finish on there. That's like some of the real micro, small metallic particles. You want to do that, repeat until the rag's like perfectly clean. You don't want any of that metal. It's just going to cause premature wear of the rings. You want the honed finish, just kind of the honed finish inside the Nicosil barrel, and that's what actually breaks your rings in. So you can see, I don't really see any of the gray particles. And generally, Malossi kits are pretty clean. If you're doing an old cylinder that's cast iron, those are going to be very dirty with particles and all that good stuff. Clean that. You can also spray a little cleaner on the rag, clean the head surface. Again, with a terry towel, because this type of towel doesn't leave fragments of rag behind. The red rags have a tendency to leave stuff behind, so hence why I like using those. Okay, you got the piston right here. Again, you can kind of clean it up. There's some writing on it from Steve. But the most important mark you need to be looking for is this little arrow that points down. And when the cylinder is installed, cam chain tensioner is on the top, the exhaust and this arrow are on the downside. So the arrow always points down towards the exhaust. So holding the piston.
Show the arrow again.
Right there. It's a very small little triangle. Before I even install the rings on the piston, I'm going to talk about the different rings and what they look like and the purpose they serve. There's a total of 5 different individual parts for the 3-ring setup that's used on this Malossi piston here. First of all, first one I always want to install is this corrugated metal ring. It's not a ring that per se puts pressure on the cylinder walls, but it's like a spring that holds the oil control rings. And the oil control rings, they keep the oil on the crankshaft side and keep oil out of the combustion side. And it's very critical that this is installed correctly. This is the easiest ring to mess up on when installation. And you can see it's corrugated. It's got a gap, like all the other rings. And that's going to be the first ring I'm going to install. And then there's a pair of identical rings that are the next, the thinnest rings that are included with the kit. They're very thin, and those are the actual scraper or oil control rings. And they do not have an orientation if they go up or down. Very thin. There's a pair of these, and it's critical on installation. These are the easiest rings to damage when you're putting the piston into the cylinder. The second ring, which is the second control, or the second compression ring as they call it, it's this cast iron, kind of looks like a graphite color ring, and it has an orientation on the way it goes up. You can see it's got like a kind of a special shape to it, but the way to key the orientation up is there's a very small N engraved in the top face of the ring, and the N is going to face up to the top, and that N is right there at the very edge of the gap. So just keep an eye for the N. And the top ring, they're usually either chrome plated or plated with some other type of hard metal. It's a different type of ring material. It's kind of got a copper color on the inside. And much like that second compression ring, this first primary compression ring has an N that indicates what side faces up. All right, starting with the corrugated metal looking ring. I have the arrow facing down on my hand there, and the lowest ring groove, as you can see there's 3 grooves. The lowest groove, I'm putting that ring right in there. And I allow that the spring, the faces touch each other right at the very top. So 180 degrees from that little arrow right there. Next 2 rings I'm going to install are the actual scraper rings. Again, no orientation to these, but I'm going to install the first one from the back side of the piston and kind of stretch it over the skirt of the piston. And just work your way, and it's going to go on the lower part of the springy ring. And I kind of have the gap a little bit off from the side of the skirt itself. It's going to drop right in, kind of hold the gap open, and it dropped right in. And right now the gap, if I squeeze the rings, a little less than 1 millimeter right there. All right, so the top ring, much like the lower ring, I'm going to install it from the top. You want to miss the upper 2 compression grooves, and the gap's going to be right around 10 o'clock or 11 o'clock. So you kind of work the ring in, on top of that springy thing. You can see the top ring, the corrugated metal, and then the bottom ring. So bottom ring gap here, top ring gap here for those oil rings. We'll install the middle ring, which is your compression ring. And the N is facing up. And I'm going to put it right down here, which is at, 4 o'clock, I guess? Something like that. So carefully just kind of work it out into the groove and don't scrape it past. I'm kind of pulling the ring. The last ring is your top ring, and it's going to go like 8 o'clock or 7 o'clock, somewhere like that. It goes in the top ring groove, and there you go. So that's popped in. So that's our rings right there. They're all installed. Not going to want to rotate them around. All right, so I'm holding the piston. You got the arrow of the piston that's going to point down, so you can call that 6 o'clock. The first ring I installed was that corrugated metal part of the spring of the oil control, and the gap is at 12 o'clock. You got the lower oil control ring, which I installed second, and it's installed around, I would say about 2 o'clock, I would say, somewhere in that range. The upper oil control is installed at 10 o'clock, so right about here. And then you got the middle ring, the kind of graphite colored ring with the N that faces up, and that's installed about 4 o'clock right here. And the very top ring with the gap, and it's installed 7 or 8 o'clock, somewhere in that range. Now we're going to go ahead and oil up the piston a little bit and stuff it. So both of these skirts, I'm going to drip just a small amount of oil just to pre-lubricate the oil skirt, or the skirts of the piston. Again, I'm kind of holding the rings to keep them from spinning around. here's my cylinder. This is the actual spigot that goes into the engine. The top of it's indicated because there's the cam chain tensioner that goes into this hole. I'm going to turn the piston around like this. The arrow is pointing down. So arrow pointing down, and away from that is the actual cam chain tensioner. And the gaps, you got to monitor the gaps as you drop the piston in. And you can see I'm tipping it just ever so slightly. Make sure the rings don't get out of the grooves, because if you try to jam the piston in without them in the grooves, you're going to end up ruining the rings and the piston, possibly the cylinder. So first ring dropped in, and the second ring, kind of use your nails and just give it very baby little taps right there. Very fragile. And then the most critical rings to get in, and the most difficult ones sometimes, got to watch the gaps all the way around. So, you know, our gap for this first oil control ring is right here. And make sure the piston kind of goes in square. See how it kind of wants to drop in funky directions. And I watched the gap close right up. I didn't see the ring actually fold out of the groove. Very, very critical that you get the rings in there. So now all the rings are just barely in the bore. I'm going to put just one drop of oil in here, and you could smear that one drop is all the oil you need in here. So if you over oil the cylinder, it's not going to break the rings in. So that one drop is just enough oil kind of to initially lubricate the rings. The next step is we're going to put one of the wrist pin clips in. And I always tend to do it where this cam chain tunnel is, because with the cam chain in the way, it's difficult to get this clip in. And much like removal, you can grab it with a very good set of needle nose and kind of start the clip in where the notch is, and roll it in. Yeah, I'm a little far away from it. Normally I like getting right into it so I could see everything a little easier, but try doing it a little bit further. Another thing is sometimes flip it around. Maybe you'll have better luck going the other direction. I always keep my finger on the clip. That's if it does pop, it won't go flying. Or it's less likely to go flying. And you inspect the clip all the way around and make sure it's in the groove, because if it's not in the groove, it's going to come out, you know, of course, at high engine speed and tear up the cylinder, the whole 9 yards. This is the gudgeon pin, the wrist pin, whatever you want to call it. I don't know why I call it the British layman term. Go ahead and lubricate. I just cleaned it with a little bit of spray cleaner. And with the pistons, I'm just lifting the piston just enough to get the pin in. So we went ahead and cleaned the base. It's all prepared, ready for the gasket. I'm going to take your 2 small dowels and drop them into these holes here. Verify your crank still top dead center with the mark you made in the earlier steps of disassembly. All right, we're going to go ahead and install the factory base gasket, the B015442 base gasket. It has a silicon extra bead there, kind of keeps it sealed up. And that silicon bead kind of faces down. So just drop it down the studs. Get to the cam chain, feed that through. Get the rod through. And set the base gasket all the way down. Get it over your dowels. Take your cylinder that you prepared in previous steps. Cam chain tensioner goes up. And you can ignore the cam chain at this point. You might think, oh, well, I'm going to pinch the cam chain in there. Not going to do that. Pull the rod up, and the actual piston pin is just partly, partly into the barrel right there. So, and you kind of got to wiggle everything until the pin actually goes in place. best to drop a rag right here. Catch your, if you accidentally lose the clip, it's not going to go. So we got the, on this side, you can see the clip's already been installed. I have a rag here to catch the clip. And I'm going to go ahead and roll the clip in. If you want to come over here, Steve. So you got the pin all the way pressed in, exposes the groove that this clip's going to set in. So I'm going to take the clip, kind of roll it in. See, I got my thumb right there to keep the clip from popping. It's definitely not in a groove right there. See how it's on the edge? And you'll hear it click right in. Just make sure it's clicked in all the way around. That's good. Pull the rag out. You use a magnet if fingers don't fit through the cam chain tunnel. Got that, and just, you know, the rings are already stuffed. Oftentimes I'll drop a needle nose I was just using and kind of just wiggle the bore in, and it should go smooth. So I'm not forcing it too much. If you're forcing it, there's something wrong with your rings, and at that point you probably already did damage to the new rings. But it slipped right on there, no problem. You see my mark right here. Double check your top dead center. Close enough. Again, all this surface has been cleaned, so take care not to get oil on anything. You'll see a little bit of oil wiped off right there. Take your two larger dowels, and it goes in this upper one. And I'm kind of wiggling the cylinder around so there's room for them to drop right in. Dowels dropped in. All right, got the head gaskets included with the Malossi kit. It may look identical, flipping at both sides, but you can see the shape is slightly different down here. This hole is larger than this one, so it needs to go over the dowel. Definitely can't put it on the wrong direction. So go ahead and drop it through. And it drops right onto the two dowels. Our head was all cleaned up in the previous steps, ready to install. My gasket fell out, but that's no big deal right now. So as you can see, I kind of like lifted the cam chain through, and make sure that cam chain doesn't get squeezed in between. All right, it dropped right onto the dowels, and that's right where you want it. Spin the 4 8mm nuts. You'll need a 12mm socket to torque them. All right, so I bottomed out all 4 of these cylinder nuts right here. We're gonna use a torque wrench that's ideal for lower torques. And you want to set it to 10 Newton meters, which is equivalent to 7.4 foot-pounds. You can do this with a mechanical torque wrench if you like, but I have the electronic one set for 10 Newton meters. And I'm going to go ahead and do this in baby steps. So just like, see I'm turning it maybe not even a quarter of a turn. You can actually watch the display. It's getting up to about 6 Newton meters. 6, 7 Newton meters there. 10 Newton meters. 10 Newton meters, and last one. If you notice, I did it in a crisscross, so boom, 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 just like that. And that's not the final torque. These engines is what you're going to need to do next is torque each one of these 3 times to a total of 270 degrees. So pretty much a 3/4 of a turn that they got to go. But we're going to do it in 3 steps. So doing 270 degrees in 3 steps is 3 torques of 90 degrees. There's 2 ways to go about it. If you're a home mechanic, you can set a ratchet on here, and right where it has tension, then go ahead and tighten it 90 degrees. 90 degrees is pretty easy because you're going from, in this situation, I'm going 6 o'clock, 9 o'clock, 6 o'clock, 9 o'clock, 6 o'clock, 9 o'clock. Crisscross once, do it again twice, and then the 3rd time, that's the final time. I'm going to use a torque wrench that has a degrees built in. It calibrates itself, set the 90 degrees. And it says right there. And it also will let me know what the final torque, which isn't really a useful number because it's your torque into a yield of 270 degrees. So I'm gonna hold it there. You're gonna see this thing count 90 degrees, 14.7 Newton meters, it says. And you gotta do this perfect, because if you mess up, you gotta loosen everything and start over again. 90 degrees. Again, if you're doing it at home, you know, as long as it's between like 85 and 95, you're probably good. So there you go. That's my first step of 90 degrees right there. Second step, I go a little faster. I'm just doing it because I hear the torque wrench. All right, third step, and it's pretty tight. 90. And you can see it kind of wants to return a little bit, and it's going up to 25 Newton meters. And there you go. It's torque right to, and I pretty much monitor them. All of them were between 23 and 26 Newton meters was the final torque. Again, this is the best way to torque these heads. You got the two cam chain tunnel 6mm fasteners. Use an 8mm wrench to tighten them. The torque's not too critical on it. I'm just doing by feel, but it's around, you know, again, 10 Newton meters, 7.5 foot-pounds is what they would normally be torqued to, but I'm just doing to feel, and that feels about what's right for a 6mm fastener. All right, so here's the can sprocket, the little arrow that I highlighted with a little bit of white paint. I verified my crank still at top dead center from that previous mark I made. You got the cam chain, and go ahead and drop this right in. And I'm kind of just doing it willy-nilly. And I'll see, oops, looks like it's one tooth off. So I want to rotate the sprocket one tooth this way. The way to do that is kind of lift the chain and see how it was like a caterpillar, just walked all the way around. And now I can tell you that's perfect right there because I see the arrows pretty much in playing with his head is pointing at 12 o'clock, and that's right where I want it. And you'll see a large hole that lines up with this, a peg that lines up with this. You can get back there and kind of rotate it around until you get that lined up pretty close, and then drop the actual cam sprocket right on there. And as you can see, there's a little bit of free play, but once the cam chain tensioner is in there, you can see that will tighten that right up. So still top dead center, arrows pointing perfectly straight up, and you can see the guide pin, you know, this hole where you can lock the cam up is still lined up right there. All right, this tricky little beast, I didn't take the spring off, but the shorter side of the spring goes against the little counterweight that's on this little guy. And it goes into this hole right here. And see how I'm dropping the counterweight further past where it needs to go? But I was able to line up the longer part of the spring with this hole right here. And I'm going to use this to hold the spring in place and go ahead and turn this all the way until it pops into the groove. There's a little pin that ends up lining up with this groove. And just to try it out, you can see that it moves freely and wants to self-return to that position right there. Next, take the lower screws in this little plate that retains the whole tensioner assembly. Put the second screw in, and you can see I didn't tighten them yet. So they're just snug right there. Double check to make sure this returns. It's sticking a little. You know, it sticks a little bit at the end, and that's normal. Just a little bit at the end is fine. Like I said, you want to have a little bit of free play between this plate and this thing. If it's making contact to this, then you need to bend it out a little bit. So I'm using something, a dowel of some sort to lock up the cam pulley, and I'm tightening these 2 Allen screws. Again, they don't need to be tightened too much. It's probably like, 5 Newton meters. It's just not very tight. And make sure that's all working good. So our cam chain tensioner, again, in a previous step, I reset it, dropped the new gasket on there, and it lines up with that as it is right there. Put the 2 screws. Spin those down. And snug both of those screws. Take the spring. And again, this has aluminum washer. Some have an O-ring, a little bit different style. And you'll hear the ratchet kind of, as you're pushing pressure on the spring, you'll hear the ratchet go through. And you know it tensioned the spring because this no longer moves. It only moves just a little teeny bit. And it self-tensions itself as the cam chain wears. All right, no spark plug in it. It's gonna be really easy to turn over. I'm gonna go ahead and turn this over 720 degrees. And just make sure everything's working. And put that back at top dead center. It lines up perfect with my pegs, so I know the timing's all good and the cam chain's tight. We're gonna go ahead and check the valves. Okay. So there's these handy little tools that will do this for you. And you can loosen the lock nut, and it's got a small square drive to actually turn the adjuster right there. So you can see my exhaust is a little on the tight side. The 0.5 fits in there, but I want to get it to an 0.8 millimeter, which is 3/1000. Better to be a little on the loose side. The other, 0.5 is probably still within spec. If it's too tight to break open, you always go in there and just open it with a regular socket. And the way you feel this is just real light tension. And right when it stops, that means you're right at the right torque. And the way you work these is you hold the lock nut and give the lock nut its final tightening. These are a little bit on the large side for these, but you can see it drags right through now. That's the way you want it. Double check the tightness on it. Again, make sure it didn't go any tighter. Perfect. All 3 valves are now set to spec, and you want to fill up this little bit of a well with a little bit of oil here. Just as a pre-lubricant right when it starts, because it's not going to have oil pressure right away. Again, this stuff was kind of oily to begin with. I didn't take it all the way apart and clean it. If it was fresh parts, you probably assemble all this stuff with assembly lube. But since we're reusing everything, it just needs a little bit of oil on, that's it. All right, so it's got a new valve cover gasket. If there's any leakage around this oil breather, replace the rectangular gasket that's under that, held by the 4 Torx screws. This is all ready to close up. 4 screws, all the same length. Just like the cylinder head, kind of do it in a crisscross. Okay. Reuse this little rubber isolator gasket, just there to keep the fan cover off or the cylinder shrouds off the metal. Pretty straightforward. We'll put an iridium spark plug in. So this is the iridium spark plug, the CR8 EIB, included with the kit. And as what I find is if you don't touch these, they're gap within specification of Vespa. So don't bother trying to gap them. You're going to end up doing more damage to the iridium electrode. You can see it looks like a needle. And if you bump that, usually will break right off. So. And side by side, you can see this 2 different electrode designs.
You have to say that again. Let me get focus. Okay.
The original plug is just a standard regular electrode. You can see how it's got that larger one, while the iridium one's got that needle, you know, precious metal iridium electrode. And the electrode will last a lot longer, and a small point will make a stronger spark versus the kind of more blunt point of the regular electrode. Pretty simple to install. 5/8 spark plug wrench. Use the remove and make sure you're not cross-threading it, and go ahead and bottom the washer out. You feel there's tension, and just go ahead and turn it another half turn once you bottom out the washer. That only applies to a new spark plug, because once the washer is crushed, it's not the same. All right, I got the upper cylinder shroud. Still has the spark plug wire is attached to it. Go ahead and drop that on. Again, the spark plug. And one thing to keep in mind is you have this little wire right here, and that's your oil pressure sensor. It drops in a little groove that's up here. It's pretty easy to see. Lower case goes in. You can see there's 3 little plastic tangs. They all line up, and they snap, and they'll hold the thing right in place until you get this. You got the 3 self-tapping screws here, here, and here. And then you got the sheet metal screw that goes into the case right there. Then last, put the fan cover on with the remaining screws. All right, the original screw that holds the front mount of the coil, it ends up bottoming out on the Malossi Kit. It's just, they don't have them threaded quite as deep. So the solution is either use a shorter screw or drop a split washer, then a standard flat washer, and then the deep washer. And Steve, what are the part numbers on those washers?
6mm?
6mm, yeah.
00356 0164 of the 6.
Yep. So you can order those from us, you know, with the kit, so you just have them on hand, and now it no longer bottoms out. You can see it spaced up a little bit more, but you definitely don't want that bottoming out or going any further, because it's not going to serve its purpose to tighten the
Don't worry about ordering those. We'll put those in that kit. Just buy that secondary consumable kit from us, and you'll be covered from now on.
So the sensor, 21mm socket, just inch it on there, don't over tighten it.
What sensor is that?
The cylinder head temperature sensor, got the intake manifold, the new gasket. And one thing about this gasket, it's kind of easy to let the gasket slide between the cylinder shroud. So if you want, you could use a small amount of grease to hold it in place prior to installation.
That gasket as well is included in the consumable kit, not with the actual cylinder kit.
All right, so the last of the intake manifold's been torqued. If you really want to tweak out on this project, you could actually port match this intake manifold to the cylinder. And I'm sure you can find lots of videos on how to do that. In our experience, it doesn't really make that much difference, you know, unless you're going to do some serious port work to the engine, maybe increase the valve size. And that's like, that would be a serious mod. So I lubricated the O-ring on the starter motor. Starter motor is kind of like a little bit of a bear to get in, because it's got to engage with the teeth. So oftentimes you just kind of wiggle it, then it goes in. Use your hand as a hammer. And I'm just going to put these in loose for right now, because we got the wire and the ground that go to these. And that concludes the cylinder kit installation. Pretty much reinstall the motor into reverse order, and we'll show hooking up the power commander and talk about the transmission and the muffler installation. All right, so motor's back in. I have everything hooked up. I'll just quickly summarize what I've hooked back up. You know, it's pretty much like I said, it's all in the reverse order. You want to route everything just like you took it all apart. You see there's your O2 sensor connection, there's your main engine connection. You got your starter and ground connections, a little wire strap, some more connections at the throttle body, and the injector and temperatures connections. There's one zip tie that I cut originally off, so go ahead and replace that. And these three one-time use hose clamps have all been replaced with reusable worm gear style hose clamps. So you have the idle control air hose, your whatever you call it, crankcase breather, and your evap hose right here has been hooked back up. And before I even put the power commander in, I've already filled up the oil. I double checked the level. But you want to make sure the bike runs before you get any further and put the electronics in. So here's our maiden start right here. There you go, start right up. Make sure the oil pressure light's out. Looks like the oil pressure light's out, so give it a couple good revs for good measure. It's gonna smoke just a little bit on the first startup. All right, we're going to go ahead and install the Force Master controller on this Sprint here. So you have all your wires. All the wire connections are going to be made pretty much in the engine bay. The first set of connections, it pretty much interrupts the signal of the fuel injector. So much like when you were installing the kit, pull the little clip. All right, so the fuel injection connection's disconnected. I have the harness from the Force Master routed underneath my fuel hose. Go ahead and plug the male into the original scooter's harness fuel injection connection, and then the new connector goes onto the injector. For right now, I'll leave these loose, but I'm going to tidy them all up with zip ties because you don't want these connectors flapping around. Going to route these up and over and back underneath the fuel hose here. This ground connection is going to go down and make connection with the belt cover ground connection. Yeah, same ground connection down below. And the yellow wire is going to make a connection to this orange and yellow wire. And you could do it right at the sensor, but I found you could do it right here just as well. And the posi tap's going to make a much better secure connection to this throttle position wire. So the way these work is you get the wire, can't really see what I'm doing too well, but you pretty much pop the slot into the to the yellow wire that you want to tap into, and then it's got a needle that will pierce into the wire. So we'll go ahead and thread that down onto it. Make sure it's tight. We'll go ahead and cut the yellow connection and just strip a small amount of bare wires and insert it into that. Don't need this. Drop the wire down into it. And go ahead and tighten down, make the connection. So the yellow wire from the Malossi fuel controller or Force Master taps into the orange with white wire that's in the harness. It goes to the throttle position sensor, and I used the posi tap to tap into the wire and then made the junction to the yellow wire with this terminal. And it's quite secure and won't come off here. And for now, I'm going to leave these all loose until further testing. Once everything's finalized, I want to zip tie all these wires and connections so they're secure and don't flap around in the breeze, as you'd say. All right. The first step of programming the ForceMaster fuel controller is setting the throttle position zeros and 100% in the box. It pretty much just lets the box know what's your throttle position, and that's how it bases how much additional fuel that this module's going to give the fuel injector. So the first one is, you'll see all three of these controllers. They have three little potentiometers, and the slot for the screwdriver is kind of like an arrow, and they all point to 0 right now. The first one you want to turn is the low, and turn it 180 degrees, and you want the arrow to point at the red arrow down below. So it says low, and it's a little red arrow. That's pretty much 180 degrees from the 0. Don't touch the throttle, make sure the throttle's closed. Go ahead and turn your ignition on. Wait till all three lights come on. Turn the key back off. Now reset that low back to your 0 position. Go skip over to your high. Repeat, set the potentiometer to the red arrow. This one's a little trickier. You want to hold your throttle wide open, so I have it wide open right now. All three lights come on, turn your ignition back off, back to 0. And then you turn your mid position to the red arrow. And all this does is it allows you to verify that your settings are correct. So you have about a 2-3 second window after you turned ignition on to verify. See, I'm opening and closing the throttle, and went from green to red. So when it was wide open throttle, the red light opened up, and as it was mid throttle, the yellow and green. So it's all been programmed correctly. So we'll go ahead and set the mid back to 0. Your last potentiometer is the 4 different built-in maps. The recommendations is, if you have a 125, a scooter that's originally a 125, you'd use map number 0 or 1, based on if you have exhaust system or not, or don't have exhaust system. This is outlined on page 33 of the included booklet with the ForceMaster and the Malossi Kit. Since this scooter started out as a 150, we're using a 150 with a 63mm cylinder kit and a Malossi's exhaust system with the decibel killer, which just another term for the baffle. And that would be curve number 3. So we'll set this to number 3. And right now it's set to 1. We'll go to 3. It's a little. So the arrow points at 3. And that's the starting point for your tuning. We're going to do some tuning without the baffle in there, so we'll have it up on a dyno, and we'll be able to fine-tune these fuel controls, which allow you to add or subtract up to 20% more fuel at the 0 to 2,000 RPMs. Next one's 2,000 to 6,000 RPMs, I think. And the last one is 6,000 RPMs to max, so it would be your wide open throttle if you're going at highway speed. Once you've completed the install of the wiring and setting of your ForceMaster, you can go ahead and mount it. Best spot on the Vespa is to mount it on this little flat right here. It will just miss the bucket. You can drill 2 small holes and use 2 self-tapping screws to hold it in place. Just take care not to over-tighten it and break the plastic. Another option is to clean this and put double stick tape or Velcro. And once you have this mounted in place, you can route the wiring. And typically I like to route it along the fuel hose with a number of zip ties. Same with securing all these.